There we go. We're working on our do now problem 1. And do now problem 1, as you will see in the whiteboard configuration, is very similar to our first set of homework problems for tonight. So what we're going to do is, first of all, we got to get the idea of what these numbers down here are telling us in terms of mole ratios. We haven't used them that way before. We've just used them as individual numbers. So what I want to do is show you, and we'll work on the Elmo to do this. I now have a pen with 2 caps. All right? So for every pen with 2 caps, how many caps do I have? Yeah. Okay. So the mole ratio of pens to caps, okay, pens equal caps, and 1 pen is the number over here, and 2 caps is the number over here. That's pretty easy, right? Yeah. That's not real challenging. However, we have to do a little insert here. And that insert is the word mole. And for both of these, we're going to insert the word mole, which is multiplying both sides actually by 6.02 times 10 to the 23rd, right? 6.02 times 10 to the 23rd on both sides, it would cancel out, wouldn't it? Yeah. And mole on both sides cancels out. So this is a simplistic way of looking at this, because we know that when we take this thing apart, we're going to have 2 caps and 1 pen. And for every, or 1 barrel of the pen. And so if we call this the barrel, every barrel is going to be with 2 caps. And that's the whole pen. So that would be like the formula, be very similar to the formula of Fe2O3, where we have a ratio here of 2 to 3. In this guy, this ratio is 2 to 3. And the ratio here is what? 1 to 2. So this goes with this, and this ratio goes with this guy. And hopefully that helps you get some feel for what we're talking about. If I give you a mole of these pens, how many caps am I going to give you? 2 moles, sure. Or 2 times 6.02 times 10 to the 23rd. That's a bunch of caps. Okay. The cap on the pen idea here is very, very helpful in getting your hands around this guy right here. Very, very helpful. So let's go back over here and let's work with this guy now. We first of all have to have a given. So our given is this part right here, yes? So we have 8.1 moles of Fe2O3. And our find is going to be right in this part, where we have moles, and that's what we're looking for, moles of iron. I'm going to just leave out that number so that we don't get lost in those numbers and get confused. Because the concept is really very simple. It's just so easily, it gets lost in the numbers so very, very easily. So, I'd like to see how we're going to start this problem. So, Arik, how about it? What are we going to have as our first fraction? Absolutely. And so what do I write? Fe2O3 over, yes indeed. That's the way we start all of our problems. All right, now, to do the next one, we have to get a mole ratio that tells us how Fe2O3 relates to, what are we looking for? Iron. Okay, so what are those numbers going to be? And let's see if Lewis can tell us. If I have, here, let's go to here. If I have one of these guys, how many of these guys does that make? Look at the subscripts. Okay, there's one of these guys. So how many of these guys will I have if I break it apart? Just like the pen. 2. You got it. Okay, so our number over here is 2, and this is going to be moles. And our number over here was 1, and this is also going to be moles. So this is our equality that gives us the ratio to make this next fraction. So what do you think, Lewis? This guy's on the top here, and we have to have him over here on the bottom. Not only the unit of measure, but also what the stuff is. So now we're going to be able to cross these out if we figure out what our number should be. So looking at our equality below, okay, looking at this, what is the number that is next to the Fe2O3 that has to go over here? What's the number next to Fe2O3? Next to mole. Yes, okay, good. So this guy is going to be a 1. Now, what do we put on the top side, Liz? Yes, 2 moles of the iron. And so this is the guy that we wind up putting up here, and this stuff over here has to be on the bottom. Since these two guys are equal, all right, that means that this divided by this is 1, because they're equal. Yes?
So does that mean that for the ratios on the right side, you're supposed to look at the subscripts?
Yes,
So
it does. Yes, if we were comparing to oxygen, it would be 1 to 3. One of these guys to 3 of these individual guys, because each one of these has 3. Isn't that cool when the pen goes behind the, like that? Or when the pointer goes behind the writing. I think that's very neat. Okay, so now the problem gets really easy, doesn't it? We can cross this guy out, we can cross this guy out, that's gone, out of our hair, don't need to worry about it anymore. We keep this, and we keep this, and we multiply the numbers, and what's our final answer going to be?
16.2.
Pretty easy, huh? Yeah? So we got 16.2, and what is that?
Moles of iron.
Moles of Fe, yeah. MOL of Fe. And we've done it. Now, all your problems that you're going to be working on in that first set of problems that takes us back here, okay, this first set of problems, which, so for the first set of problems, which is page 321, 20 to 24, that's what you're going to be doing in all of those. Okay? Now let's see what we're going to be doing in our second set of problems for tonight, which is 25 and 26. So let's go to our second example, which is very similar to that. Oh, we've got to go down here below. Let's look at some of this stuff. This is really good. Okay, I've got this thing written down there, and this is essentially a 1 mole to 2 mole relationship. Whether we do it here like this, using moles, or whether we use it as 6.02 times 10 to the 23rd times the 1 to 2 ratio. Huh? That's why we can add moles in there. Or we can add 6.02 times 10 to the 23rd there. Either way, we multiply both sides by the same thing. We still have the equality. And I think this part right down here is really good as well. So let's take a quick look at this. One of the students a couple of periods ago had a question about something, and we went through this. 1 mole of the Fe2SO3, so this is iron sulfate instead of iron oxide, which is what I have in your actual example. 1 mole of this will give us, you see this number right here? 3 sulfates. So the ratio of this guy, 1 of these to 3 of these, is our ratio. And that would be individual atoms or moles of atoms. Making sense? And now down here, if we're talking about iron, why is this guy going to be 2? Because of that guy right there. That's what nailed it down. The subscripts are what you want to use. And now why is this 12? It says SO4. Why is it 12? Yeah, this guy is distributive. Okay? It gets multiplied by this, and it gets multiplied by the 1 that we don't see for the sulfur. So how many sulfurs do we have? 3. And how many oxygens? 12. Yes. Okay. So that's how that guy works. And then if we say sulfurs, you see we could go by individual atoms now too, which is what we're doing. Okay, so we have 3 moles of sulfur. Whoops. Come on. There. We have 3 moles of sulfur down here because this 3 is multiplied by 1, giving us 3 sulfurs. Okay, that's good stuff. Now let's go down here and let's do the atoms in this guy. How many nitrogens? 3. Good. How many hydrogens? 4. 12. Yeah, because of the 3 out here. See, this multiplies by 1 to give us 3 nitrogens, multiplies by 4 to give us 12 hydrogens, phosphorus,
1.
and oxygens.
4.
All right. Carbons.
6.
Yes, that's multiplied by the 3 over here. And let's get this up in here a little bit more so you can see better. That better? Okay. And how many hydrogens?
9.
And oxygens?
6.
There you go. See how it all works? I love these little guys. You can just throw them off the side. Isn't that wonderful? Okay, so let's go to this one and start from scratch again. What is the molar mass of magnesium sulfate? That's our second do now. Okay, it's similar to this. It's going to be worked exactly the same way. So, we're given this guy. So that's magnesium sulfate. And we're supposed to find molar mass. Of magnesium sulfate. I hope you guys are writing this down. When you sit down on this weekend to do this stuff, if you're not writing it down, you're going to be up the creek. So, now we have our given and find set up. This isn't the same kind of calculation that we've been doing with a bunch of fractions, okay? This is different. This is a whole different animal. So we have to know what this means. How do we do the molar mass of an atom? Periodic table, okay? So open up the inside back cover of your textbooks and let's start looking. So I'm going to make a column here called molar mass. And these will be the atoms that are in our molecule. And the molecule, of course, is this guy. So, who's our first atom? Magnesium, okay. And just to double check here, I'm going to kind of call on you through the cards. Floor, what is our mass, molar mass for magnesium? See, if we do it this way, it's pretty easy, isn't it? Because we're just doing the atoms.
It's
24.3. Okay, so it's just one magnesium. Now, let's do sulfur. Anto, tell me about sulfur. How many do we have? How many sulfurs do we have? You're not going to find how many sulfurs in there. You're going to find how many sulfurs by looking at this. No. No. This, okay. Yeah, the error that you just got on this was he took the 4 and made it go to both the sulfur and the oxygen. It just goes to the sulfur. And I know you know better. So it's an easy mistake even when you know what you're doing. So let's go ahead and continue then. We got sulfur, and how much? We got one of them. And what's the molar mass of sulfur? That you need your book for. Sulfur is what? 32. 32.06. I'm going to round that to 32.1. Okay? Just one decimal is fine. And now for the last one, the last atom, Valerie. Okay, could you tell us about how many oxygens we have? How many oxygens? How many oxygens in this? Yeah, okay, good. So we have 4 oxygens. What does that mean we're going to need to do with the molar mass? Yes, 4 times. And so what do we get for the molar mass of 4 oxygens? Yeah. Just make it 16. 16 times 4. Yeah, 64.0. And now all we have to do is add it up. This is really easy. Okay, straight addition. 4 and 6 and 4 is, oops, not another 4. 10. 1. Oh, carry the 1, and we got 120.4. What is that? That is the molar mass. And what is molar mass? It's grams per mole of magnesium sulfate. There you go. And there's our answer. Isn't that easy? Yeah, really easy. So typically what happens is, in the problems that you're going to be working with later on, you'll need to find the molar mass of the molecule to be able to change the grams of one of the things in a reaction into moles. Just like you had to find the grams of the individual atom and change that into moles, you'll have to do that now on a molecule basis. And remember, a couple of days ago, I think, I said this guy, and we realized that the molar mass isn't 14. Why? Because we had 2 of them and we had to add them up. So because it's N2, the molar mass would be 28, where if we had just the N, that would be equal to 14. Okay, I hope this helps.